Give it examples of what the water pressure looked like just before a pipe burst, or how the flow of water changed when a tiny crack started to form. The AI analyzes all these examples of bad situations. It's like a doctor learning to spot the early symptoms of a sickness. The AI becomes an expert at recognizing the warning signs that signal a leak is about to happen. The more data the AI gets, the smarter it becomes, getting better and better at telling the difference between a normal pipe and one that is in trouble. AI is super smart, but it can't see or hear what's happening inside our pipes all by itself. It needs a partner to gather the information, or data, that it needs to do its job. This is where sensors come in. Sensors are like the eyes and ears of the AI system. They are small devices that we can place on or inside the water pipes. These little gadgets are constantly working, measuring all sorts of things. They can measure the pressure of the water, how fast the water is flowing, the temperature, and even the sounds the pipes are making. They are on duty all day and all night, collecting a steady stream of data. Think of it like a team. The sensors are the field reporters, out there on the front lines, gathering all the latest news from the pipe network. They collect tiny bits of information every single second. For example, a pressure sensor might report that the water pressure is stable at a certain level. An acoustic sensor might report that it only hears the normal whoosh of water flowing. A flow meter might report that a consistent amount of water is passing through a specific point every minute. All this information is then sent wirelessly to the AI, which is the editor-in-chief back at the headquarters. Once the AI receives this constant stream of data from the sensors, it gets to work. It compares the new incoming information to the patterns it has already learned. The AI is looking for any tiny change, any little thing that is out of the ordinary. It can then pinpoint the location of the potential problem and send an immediate warning to a human operator, long before any water ever shows up on your floor. This amazing technology is not just a cool idea for the future. It's already being used today to prevent disasters. For instance, a large apartment building in a big city installed an AI leak prediction system. One night, the AI sent an alert to the building manager about an unusual flow pattern on the 10th floor. A maintenance worker checked and found a small corroded fitting on a hot water line that was about to fail. They fixed it in under an hour. Without the AI, that pipe would have burst, flooding several apartments and causing hundreds of thousands in damage. The AI's prediction saved the day. Water companies in London are using this technology to manage underground pipes. Water companies in Los Angeles are doing the same. They analyze data from thousands of sensors across the city. The AI identifies which old pipe sections are most likely to break next. That lets crews fix weak pipes before they fail. Proactive repairs save a huge amount of water. They prevent traffic chaos. They ensure reliable water supply for millions. It's a smarter way to manage city infrastructure. The benefits are clear. At home, it means peace of mind. A smart system watches over our pipes, protecting homes from water damage. For communities, it means conserving water. It leads to more efficient cities, lower water bills, a healthier environment. AI quietly works behind the scenes to make life safer and more sustainable. As technology advances, more smart solutions will join everyday life. Smart homes that manage energy use. Smart cars that drive themselves. The future is smart, and it's here to help.